So, welcome to everyone. The the next topic is Unit 3 contains. The Unit 3 content is design of rigid pavement. In that unit, the the topics contains with the cement concrete pavements, factors influencing CC pavement, and the modified Westergard approach, and also the design procedure as per IRC guidelines, and also we are using concrete roads and the scopes in India. So first of all, we are seeing about the Western Guard approach. In that Western Guard approach, we are seeing about the first the design of rigid pavement by the Western Guard method. Still, it is commonly used today for rigid payment loaded by non-heavy highway vehicles. So a lot of test is there in the flexible payment. Only we are focused about the rigid payment, that is called the Western Guard approach. The Western Guard method for the rigid payments a design that is involves a calculation of the stresses acting in the payment under the wheel load. This stress is then compared to the strength of pavement slab to determine whether the slab is sufficient strong to accommodate the proposed loadings. So the Western Guard analysis of the rigid pavement stress and strength is often combined with a separate fatigue analysis model to determine how many repetition of these loads the payment will be able to withstand. The next topic is in that Western Guard approach, the loading condition will be occurred by various spaces. That is, the first one contained with corner loading. So this is the corner loading condition. If you are acting on a wheel load, the wheel load stress and distribution will be acting some loads in corner. That is called the corner load, and also some loads will occur in internal loading condition in the road payment rigid payment, that is called internal loading condition. And third one is using by edge condition. So normally the edge loading condition is very problem to payment design, because if you are acting any load in edge condition, edge type means the payment will be heavily damaged, so that we will protect the payment in the edge loading condition. So the next one is, these are the Western Guard analysis for rigid payments, that is interior slab loading. So in that we are using some clear definition for the stress and deflection to also analyze the distribution load, that is rigid payments in the some interior slab. So in that first one is a plan view of slab system, and then where it will be occurred the point of contraflexure and wheel load, that is with the radius of alpha, and also the deflected shape of a pavement slab, and finally it will be occurred in the bending moment diagram, and also point of the maximum deflection radius of curvature to be calculated in the bending stress. So these are the some joint practices in payment, rigid payment. So first one is a expansion joint. These joints not good practice with good design in a contraction joint. So first one is it will be used the joint sealant material and also joint filler material to the expansion cap, and also it will using a double bar. So the double bars will using in the rigid pavement, which means the double bar acting on a combination of comparison between the bond capacity of the two joints, that is in the rigid pavement. And also we are using tie bar in the diameter in the case of 0.15D and 0.2D and also 0.5D for the case of 0.1D gap between the joint practice. So there are more number of joint practice we are using. The first one is traverse contraction joint, and also it will using a sound formed or tooled groove in a concrete slab that creates a weakened vertical plane. It regulates the location of the cracking caused by the dimensional changes in the slab and is by far most common types of joints in the concrete pavement. The next one is a longitudinal joint, a joint between two slabs which allows slab warping without appreciable separation or cracking of the slabs. The third one is a construction joint. In a construction joint, the joint between slabs that results when concrete is placed at a different times. Finally, this type of joint can be used for further broken down into traverse and longitudinal joints. And also, we are seeing about the expansion joint. In an expansion joint, a joint placed at a specific location to allow the pavement to expand without damaging adjacent structure or pavement itself. So these are the some topic really about the joint practice, and also we are seeing about the causes of distress and pavement evolution, current issues, components, stages, and also defects in the rigid pavement. What are the defects in the rigid pavement? It will causes the various damages, including the edge failure, scaling, shrinkage cracks, and warping cracks, and also construction cracks, blow-off cracks, tenting, structural breaks. So these are the fault and depression in impact of riding quality, and also unequal settlement of the joints, and also the absence of load transfer devices at the joint. It will use the impact effects of load at the joint. By consolidation and shear failure, relative great length of the defected area, gentle scope, deep foundation moments, and also it will provide a leveling force to restore the riding quality of the pavement before the resurfacing operation. So finally, the faulted or depression joint which will occur imperfect riding quality and also the unsettlement of the cracks. So these are the defects of rigid pavement. So thank you. So today we seen about the what is Westergard approach and what are the test practice we are using in the rigid pavement. Thank you.